Hello everyone and welcome to the Hooks Law Higher exam model answer. A student carried out an investigation to determine the spring constant of a spring. The table below shows the data obtained by the student. So in the table we can see we've got force and we've got extension measured in centimetres. Describe a method the student could have used to obtain the data given in the table above. Your answer should include any cause of inaccuracy in the data. Your answer may include a labelled diagram. Okay, so this is a 6-mark question and it is about the Hooks Law Required Practical. So what we're going to do is we're going to have a diagram so we can remember ourselves how we can write this down. So we're going to need a clamp stand with a clamp on that. We're going to be hanging a spring from the clamp. We also need a second clamp and a boss to fix a meter ruler alongside the spring. So this is going to be my meter ruler. It will help as well if you label your diagram. So we're going to do ruler and spring and clamp stand and then clamp. Okay, so I'm just going to put a few bullet points down about that, and it's fine in a 6-mark question to do bullet points, especially if it's a method. So set up a clamp stand with a clamp. Secondly, hang the spring from the clamp. And then we've got to talk about the ruler. So use a second clamp and boss to fix the ruler alongside the spring. Okay, and then we're going to record the meter ruler reading at the bottom of the spring. So record ruler reading, level with the bottom of the spring. Then what we're going to do is we're going to hang a 2 Newton weight from the spring. Hang a 2 Newton weight from the spring. And then we're going to record the new position of the bottom of the spring. And then we're going to calculate extension. The extension. So just a little reminder about extension. So say this is my spring with no weight on it. When I put weight on it, it's going to stretch. The extension is the difference in length between the original length of the spring and the new length. So that bit there would be the extension. And that's what we need to calculate. Okay, so then we're going to do more weight. So add more weight to the spring, going up in 2 newtons each time until 10 newtons is reached. Okay, and then for each one of those, we're going to measure the extension. So measure the extension each time. Okay, so we're not finished there yet because the second part of the question asks us about accuracy or in sources of inaccuracy. So possible sources of inaccuracy is not clamping the ruler vertical. So say if I were doing this and I put my ruler and it wasn't straight down, it would give me an inaccurate reading of the length. So inaccuracies okay, not clamping the ruler vertical, which will give us what we call a parallax error. You could also misread the position of the bottom of the spring. So misreading the position of the bottom of the spring. Okay, so all these things would make us have inaccuracies in the data that we've collected. So that's an example of a 6 marker about required practicals. So you do really need to know these required practicals. Okay. Right, for question B. The student measured the extension for 5 different forces rather than just measuring the extension for 1. Suggest why. Okay, so why they would do this, so they can identify sources of random error, so they can calculate an average for the spring, and also to identify any anomalies. Remember, anomalies are results that do not fit the pattern of the data. The diagram below shows some of the data obtained by the student. So they've started plotting a graph about this. And the question is if we can complete the diagram by plotting the missing data from the table. Draw a line of best fit. Okay, so they've plotted for 0 at 0. They've missed the plot for 2. So we need to work out our scale first. You can see that this is 5 and in there I've got 10 squares. So each 2 little squares is going to be 1. So my point at 2 is 3.5. So it's 1, 2, 3.5. So I'm going to put a plot there. My point for force of 4 is plotted and 6 is plotted. For 8, it's 16. So I'm going to go up to 15 and 2 little squares above, like that. Then I want a line of best fit. So for these questions, we're looking for a nice straight line. It's Hooke's law. So I want to have a line of best fit. So you need to put your ruler through the lines, try and get them all matched up as best you can. If not, then you need the same amount of crosses on each side of the line. So that would be an example of my line of best fit here. For the next question is write down the equation that links extension, force and spring constant. So for this one it's force equals spring constant times extension And then we've got to work out the spring constant of the spring that the students use. So for these questions where you've got a graph and it's a straight line graph, the spring constant is the gradient. So if we have a look at our graph, we need to find out some values from here. Because it's a straight line, I don't need to do my little triangle method underneath because the straight line's got the same gradient throughout. So I'm just going to use the last coordinates here. So force is 10 newtons. We'll write that down. And my extension is 20 centimetres. Okay, so we need to check a few things before we put this into that equation. Force is in newtons, which is correct. Extension is in centimetres, it needs to be in metres, so we need to divide that by 100. So I get 0.2 metres. For the spring constant, it's going to be force divided by extension. So it's going to be 10 divided by 0.2, which gives a spring constant of 50 newtons per metre. Okay, and then the last question, the last part of this question, Hooke's law states that the extension of an elastic object is directly proportional to the force applied, provided the limit of proportionality is not exceeded. The student concluded that over the range of the force used, the spring obeyed Hooke's law. Explain how the data supports the student's conclusion. So if we have a look at the graph, if we obey Hooke's law, we've got a direct proportionality. So that graph is an example of something that's directly proportional. And it also goes through the origin. So for 2 marks here, we're going to say the line is straight, directly proportional, and we're also going to say that the line passes through the origin. Okay guys, so hopefully you've done really well on those questions. Well done for giving them a try. If you've stuck or if you've got any more questions to ask, then please email me about it. Thank you.